Modeling, Topic 4, Portfolio Optimization by Lou Gaddis. References for this material include Financial Modeling, 4th edition by Simon Beningas, Chapters 8, which covers portfolio models, Chapters 9, Calculating Efficient Portfolios, and Chapter 12, Calculating Efficient Portfolios Without Short Sales. Section 1, we are going to construct and graph the envelope portfolios. The rest of the topics involve calculating capital allocation lines and finding optimal portfolios. So let's go to our data. You can see I have a start file set up, and what we have here are let's pretend we have three risky assets. SPY, which is the S&P 500 ETF, EFA, which is an ETF that tracks the developed world minus North America, and an emerging market ETF, EEM. So, one way to think about the course so far is in topic 1, we covered how to calculate the expected return. Let's say these returns were based on CAPM and global CAPM and historical data and a little bit of judgment, and I've come up with my best guesses of the expected return expected return for SPY, EFA, and EMA. Topic 2 was calculating the standard deviations of assets using things like the Black-Scholes implied volatilities and EWMA. Let's call this my best guess using that data of the volatilities of SPY, EFA, and EMA. And if we start off with equal weight portfolios, say 33.33% invested in each. Let's put a little extra in the last one there. So if we have a portfolio that's roughly 1/3 invested in each portfolio, that portfolio return is simply going to be the weighted average, the sum product of the returns times the weights. This is topic 3. Topic 3 also was about how to calculate this number here, the standard deviation of a portfolio. And we said that's going to be W transpose SW, which is the matrix multiplication of the weights and the covariance matrix. Notice here, if you zoom out a little bit, I have a covariance matrix over here. That was based on my judgment of correlation matrix that I calculated using a decade of data. So these are the S&P, EFA, and EMA correlations. Based on those correlations and these volatilities, I then got the covariance matrix, which is vols times transpose vols times correlations. I then can calculate the standard deviation of that portfolio. That was topic 3. Now, topic 4 is really deciding what are an optimal set of weights to construct a portfolio that combines these three assets. And then furthermore, if I have a risk-free asset or borrowing, how can I create even better portfolios that combine borrowing and risk-free assets? A little note here, I have a couple named ranges already set up, or range names. Notice this one here is called mean, the mean portfolio mean. This one here is called vol, that's portfolio vol. W sum is the sum of the weights. This is W. These are vols. These are means. So it's the mean returns for the assets. So again, I've got means, vols, W sum, mean, and vol. Later I'll show you that I also have sharp and B sharp. So what we're going to do is go back to our PowerPoint, and what we see is the first thing I want to talk about is creating an envelope portfolio. Now, when we talk about an envelope, that's going to be a combination of risky portfolios. Let's just define a risky portfolio is any portfolio with a standard deviation greater than 0. An efficient portfolio is one that either maximizes return for a given volatility or minimizes volatility for a given return. A set of efficient portfolios is called the envelope or the efficient frontier. Now we're going to find that envelope of efficient portfolios by either maximizing expected return or minimizing vol with constraints. If I'm going to maximize mean return, my constraints will be to set a vol target and make sure all the money is allocated, the sum of the weights equal 1. If I'm going to minimize vol, I'm going to give it a return target and also have a constraint that the sum of the weights equal to 100. An optimal constraint is whether or not you want to allow short sales, in other words, negative weights. So an optimal constraint is that non-negative weights are constrained, so the weights have to be non-negative. So in other words, no short sales. So let's go build our envelope. So what I have here, again, this is my portfolio of 3 risky assets. Notice I have a link to vol, a link to expected return, a link to the weight of SPY, a link to the weight of IFA, and a link to the weight of EMA. That's going to allow me to simply copy and paste this to this area in a little bit. So what I want to do is I want to find my first efficient portfolio. And that first efficient portfolio, I'll call that portfolio 1, is one that minimizes vol for a 6.5% return. So what I'm going to do is I'm going to run solver, data, solver. I'm going to reset solver. I'm going to do a reset all. And now what I'm going to do is I'm going to minimize vol, which is this cell right here, C5, by changing W is D2 through D4, add a constraint that the mean, that is B5, is equal to 0.065. All right, so I got minimize vol by changing the weights, which is W. Mean equals 0.065. I want to add another constraint that W sum, which is D5, is equal to 1. I want to make sure I invest all of my money. Now I want to make a solution here which has no short sales, so I want to make sure this box is checked. Make unconstrained variables non-negative. So that's already checked. I think that is a default. So now I'm going to solve. It says solver found a solution. I'll hit OK. It looks like that solution is 100% SPY, which gives me 6.5% return. That portfolio is right here. I'm going to copy, click it right here for graphing, and I'll hit right click, paste special, and hit values. Well, let me show you a shortcut for that. I'm going to delete that. I'm going to copy, and I'm going to hit Alt-H-V-V. That's 4 keystrokes, and that is a shortcut key or a menu or a shortcut series of keys to paste special as a value. Now I'm going to repeat this exercise and find the best 6.75% portfolio, 7, 7.25, 750, 775. So let's do the 675. Data, solver. The only thing I need to do is change the constraint on mean to 675 and hit solve. Solver found a solution. It is 80/20 SPY and EMA. I'm going to grab that portfolio, copy, Alt-H-V-V, Alt Hector Victor Victor, Alt-H-V-V. I'll then find the best 7% portfolio. Changing that constraint to 7. Looks like it's a combination of the 3 assets. Copy, Alt-H-V-V, find the best 7.25. Paste, 750. Solve, copy, and do the last 775. And notice that last portfolio is 100% EMA, the emerging market. So you can see what's happened is you now have a series of 6 portfolios of increasing return and expected return and volatility. Notice the safest asset here, the lowest volatility, is SPY, the highest is EMA. And what you see is the portfolio is constructing assets that go from 100% of the safest to the 100% of the riskiest. And then the portfolios in the middle are combinations of those 3 assets. Now I want to graph these. So if you just select that range in which you have vols first and expected return second, and I'm going to insert an XY scatter with a line. I'm going to zoom out a little bit. I'm going to put that in this spot right here. And I want to add a few elements here. I'm going to click on the graph, design. Let's get one that has a grid. I'll pick this one right here. And let me do a quick layout and add some titles. Where it says axis over here, I'll go ahead and put the expected return. And the x-axis is volatility. I'll make this a little bit bigger. And we'll call this topic 4, portfolio construction. All right, so now I have an envelope of 6 efficient portfolios. If I wanted to add another portfolio to, actually let me add an asset to this. Let me add EFA, this asset, to this graph. I'm going to right click on the data, right click, select data. I'm going to add EFA name, EFA's X value, which is the 18% vol, and EFA's standard deviation, or expected return, I'm sorry, the Y value. And notice there is EFA right there. Notice EFA is now completely dominated by the envelope. So what we've determined here is no one should ever hold EFA by themselves, because if they want this level of return, 675, I'd rather own this portfolio right here, which is portfolio number 2. Has the same level of expected return, but less volatility. If I wanted this level of volatility, I'd rather get this portfolio right here, which is pretty close to portfolio 3. Notice portfolio 3 completely dominates EFA. It has higher return and less volatility. All right, so this is the magic of diversification. I can construct portfolios that dominate other risky assets. So we have our solution. In our next topic, we're going to construct or add a risk-free asset and construct a capital allocation line.